Hello all, me Ms. Rasika. Welcome you all in this video of standard template library. When I started programming and started googling for it, then I come to see that many professional programmers are using some fancy heavy and new keywords and functions. Then I start searching for it and come to know about this standard template library. Many of us has visited to library, but why we choose library only? Yes, library contains many books, magazines, or say it is source of content. Similarly, STL works. STL is newly added concept in C++. With using STL, it is again easy to do generic programming. The standard template library, STL, is a set of C++ template classes to provide common programming data structures and functions such as lists, stacks, arrays, etc. It is a library of container classes, algorithms, and iterators. It is a generalized library and so, its components are parameterized. A working knowledge of template classes is a prerequisite for working with STL. Predefined functions in STL helps to easily manipulate many data structures and algorithms. It saves considerable time and space in program development. As STL is generic, it is free from data types barrier because they use template for its implementation. Again, it is also easy to achieve code reusability using STL. Components of STL. There are three main components or building blocks. 1. Containers. Holder classes which is capable to store collection of data. 2. Algorithms. Collection of steps to perform the operations on container objects. 3. Iterators. Pointers used to access the element of the containers. Containers used to manage collection of objects. They are implemented as class templates. They do all the storage management of object they are holding. They provide list of functions to access and manipulate the contains of container. They provide list of functions to access and manipulate the contains of container. Containers are of three types. 1. Sequence, e.g. list, vector, implement data structures which can be accessed in a sequential manner. 2. Associative, e.g. map, set, implement sorted data structures that can be quickly searched. Log n, complexity. 3. Derived, e.g. queue, stack, provide a different interface for sequential containers. Next important is algorithms. If we want to code something, then we need to do it physically, but using algorithms it's really easy to work. Algorithms are collection of steps. Algorithms acts as containers. The header algorithm defines a collection of functions especially designed to be used on ranges of elements. They act on containers and provide means for various operations for the contents of the containers. Algorithms are used to perform the operations on container objects. Famous algorithms are searching, sorting, initialization, etc. STL algorithms can be classified into 1. Retrieving algorithms, 2. Mutating algorithms, 3. Sorting algorithms, 4. Searching algorithms, 5. Relational algorithms. And here we come to last but not least component of STL. Yes, it is iterators. As the name suggests, iterators are used for working upon a sequence of values. They are the major feature that allow generality in STL. Iterators are used to access the element of the containers. Iterators are similar to pointers. Iterators are used to point at the memory addresses of STL containers. They are primarily used in sequence of numbers, characters, etc. They reduce the complexity and execution time of program. Iterators are of four types. 1. Input iterators, to read sequence of characters. 2. Output iterators, to give sequence of characters. 3. Bidirectional iterators, to move forward and backward in containers. 4. Whatever we did earlier was from theoretical part, and I really think that unless and until we implement it in code it is none of use. So let's go towards coding part of STL. Our first code is of algorithm. We all must be known with heap sort. If we go to do hard coding of heap sort, it goes to number of lines of code or LOC and randomly an hour to work. But did you know it takes just 3 minutes to complete? Yes, this can be done by using STL. While doing heap sort, there are two main phases of heap sort. One, create heaps, and two, sort them. Those two steps are two functions in heap sort algorithm as make heap and sort heap. This program have following main steps. 1. Add directory algorithms. 2. In function main declare and define array. 3. Call function make heap with two arguments, array name and array name plus its size. 4. Sort heaps by calling sort heap method, with arguments same as make heap method. 5. Further processing of array. Here screen shows the code for heap sort, where line number 2 include the algorithm library. Line number 6 defines the array, with elements in unsorted way, and heap sort is done at line number 8 and 9, and then our sorted array is ready to display. Let's quickly look for sorted array. Our second code is of container as well as iterators too. If you have implemented linked list earlier, then it surely take half an hour to implement it. Let's do that work in 5 minutes. As we can see, gives code is of singly linked list. For it we need to follow following steps. 1. Include STL for lists. We did it at line number 3. Second step is to create object of list class. Be sure that while creating object you must have to declare object's data type also. Here we are creating integer object as first. Then it's time to add elements in list. For these we are using a method pushback. Once all elements are entered, it's time to display them all. Here we are using iterators to move through list. Here we are creating integer iterators named as IP. Here two methods, first.begin and first.end, shows start and end of list respectively. Here we are accessing list items using iterator IP and displaying them. Now let's take a steer from how it works